This is the experiment of generation of VI plot of a PMOS transistor. So first go to terminal. So in the terminal, first prompt should be CSH, then source space /home/install CSHRC. Here you give virtuoso, click on enter, wait for some time, a pop-up will appear, it takes time. Okay, so many skip games. So in this pop-up, we'll just maximize this pop-up. Click on file, go to new, library. In this we'll just give a file name something, then attach to an existing thing. We'll click on apply. So when this pop-up comes, technology or library, you'll have to go and select GPDK 180. Okay, then click on apply, then click on OK. Okay, then come to file, go to new, cell view. In cell view, we'll give some name, then click on OK. Okay, now the cell view came. So in this, we'll just maximize this. So in this thing, now I'll just click I on the keyboard. Now I'll go to browse. So in browse, we'll go to GPDK 180 and I'll select the PMOS thing. PMOS. Then see, in this thing, if you give spectre, you won't get the output symbol. So you have to click on spectre. Okay, we'll just click this. Then again, I'll click I on the keyboard. Then after PMOS is done, we have to go to analog library. In this, we need two voltage source, VDC symbol. Then we'll keep this one thing here, one more thing here. Okay, then after this, again I'll click on I. We'll come here, we'll select ground, GND, total 3 grounds we have to keep. Click on symbol, one ground over here, one ground over here, and one ground over here. Okay, so these are the components. I'll click on escape, then I'll click on this particular button, so this gets maximized. So now here I'll click on this and I'll click Q on keyboard, clean. Okay, then in this we'll give the DC voltage as minus 1.8 volt. Okay, click on apply. So minus 1.8 came. Click on OK. So I'll click on this, I'll click Q. DC voltage is VG. Click on apply. Then I'll click on OK. Okay, then after this, now we have to do the wiring. I'll click W on the keyboard. First W, then I'll connect this one to ground, then this point to the gate, then this one to the source point, then this one to the bottom, and this one to the ground, and the center one also should be connected to the bottom thing, same as NMOS connection only. Okay, connected at this particular point. Okay, wait 1 second. So there was a mistake in the wiring. From W, from this particular point, you connect it to here only. Okay, it should not be over here, it should be over here. Okay, after this wiring is done, click on this button. So if there are any errors, it will be detected. So there are no errors. So after this, after the circuit is done, go to file, launch ADEL. Then you click on variables, copy from cell view. So this value should be minus 1.8 volt. Then go to analysis, choose DC analysis, select DC, component parameter, select component, this particular component to select, give DC voltage, click on OK. Then again we'll come back to the same pop-up, this particular thing. So in this I'll give start as 0, stop as minus 1.8 volt. Then we'll click on apply, then I'll click on OK. After this is done, now we'll give outputs to be plotted. Select on design. So we'll have to select this particular point. This is the drain point. So after selecting the output, we'll come here, we'll just take this mark, then we'll go to tools, parametric analysis. So in this we'll come to add variable. So I'll select VG from 0 volt to minus 1.8 volt. Then I'll click on this run button. So this is the output. Okay, so like this you need to get in negative voltage also, even current in negative. So then we'll go to access, sweep, then in this instead of DC I'll select it as VG, then instead of news sub window, I'll give it as new window, then I'll click on OK. Go to access, sweep, then I don't know why VG wasn't selected. Now VG got selected, then I'll give it as new window, then I'll click on OK. So this is the next way. So in this, what I'll do is I'll go to marker, I'll go to create marker, let it be vertical, I'll click on OK, then I'll zoom only this particular point, like this total here, in order to find threshold voltage. So we can keep around over here, so, or you just keep over here, you'll get to know the voltage. Minus 48 point, this particular value is the threshold voltage. It's like it's still 0.0 amp rate, so that can't be. So you see where current is starting, so it will be like somewhere over here. It's still 0 amp. So you just move over here, see here 1 minus, so where it started now, so that particular point. So to be more specific, around 51 or 50 approximate, minus 51 millivolt, you'll be getting the voltage thing. Okay, so this is the experiment for PMOS analysis.